Okay, so here we are, 6.5b, and we are getting into slant asymptotes and missing points. And this is the equation that we used back in example 3 in video 6.5a at the end. And just want to look at one thing that I didn't mention. I don't know if you even care or notice that there's a line above the C. In statistics, the line above the variable means average, or actually it means the mean, which for all intents and purposes is the average, and that's what they were talking about, the average cost of building these Stanley golf carts. Okay, so anyway, back to this problem, slant asymptotes and missing points. All right, it says here that, well, let's go ahead and put this in the correct order. Again, I don't like it when it's all messed up, and I like the x squared first. Doesn't really make it wrong if it's not, but it's just kind of how I like it. All right, so let's get the other one out of here and put the one I like right here. All right, so what do you notice about this? You notice that the top exponent and the bottom exponent, the top one is a 2 and the bottom one is an x. And if you remember, if the top one is bigger than the bottom one, there is no horizontal asymptote. But, I know there's always a big but, if the difference between these two is 1, because this one is actually x to the first power, so the difference between these two is a value of 1, then we get what is called a slant asymptote, which means you've got your graph here, and your asymptote may look like this, and you may have a vertical asymptote, and you may have a graph that does that. Okay, so just to let you know, there are things other than just your vertical and your horizontal. Okay, so that's the rule as far as finding out if there is a slant asymptote. Okay, so if there is, how the heck do we find the thing? Bottom of page 482 gives you two things. One, you divide the numerator by the denominator, getting a linear function plus a rational expression with a constant numerator, which is basically the remainder. And when you're dividing, this one in particular, it's a lot easier than doing long division or doing synthetic division. We just divide each part of this by x. That cancels. One of those cancels. And we get x plus 13. We get that for our answer. Okay. All right, so what do we get here? We divided by the denominator, which you actually could do this if you wanted. Okay, so you get x squared. You end up getting the exact same thing as doing it this way. But I did it, this long division, to show you this is the remainder. Okay, this 25 goes down, you get 25 over x. So we ignore the remainder. All we're going to look at is the before the remainder. That, my friend, is the slant asymptote. X plus 13 is your slant asymptote, which means that if you're going to graph this, y equals 1x plus 13. That's putting it in the form y equals mx plus b. M being your slope 1, 13 being where it crosses. So it's going to cross at, let's say, well, let's just say these are 2, 4, 6, 8, 10, 12, 13. And then we're going to go up 1 over 1, up 1 over 1. So our slant asymptote looks like that. Okay, so that's pretty much how you find that slant asymptote. And then you can go ahead and graph this guy, knowing, first of all, what the vertical asymptote is. Now let's find the vertical asymptote real quick. Notice we have our original problem. When is the denominator 0? The denominator is 0 when x is 0. So that ends up being our vertical asymptote. Okay, so then we can graph from there. Okay, let's look at example 4. Okay, so there's example 4, and we know right away that our numerator is bigger than our denominator, so there's no horizontal asymptote, but there's a difference of 1 in the exponent, so we know that we have a slant asymptote. So we have a slant asymptote, and we also have a vertical. Notice, if you have a horizontal asymptote, you can't have a slant asymptote. If you have a slant asymptote, you can't have a horizontal asymptote. Okay, so just something to remember there. Gosh, if I'm remembering my college algebra correctly from a million years ago. But anyway, I think I'm almost positive that that's the way it works. So anyway, so we've got pretty much with this 2 different things that we're looking at. One is our slant asymptote, which means we are going to divide this out to find out where our slant asymptote is. And what we want is we want a linear function. We want to divide these two, and it will always work this way. And it will work because this will always be 1 bigger than this. So that when we divide these out, we get a function that's a straight line. We get a linear function. Always, okay? Our exponents will disappear. So if we do our handy-dandy synthetic division, now again, this has got a 2. We don't have an x, so we have to put a 0 there, and then we have a 4. So let's go ahead and do our division. Okay, so our answer for this is x minus 2 factored out of that when we're left here with an x plus 2 plus 8 over x minus 2. So our slant asymptote is this right here. That's our answer here minus the remainder. So let's go ahead and draw that. And so y equals x plus 2, meaning I'm crossing my y-axis. My y-intercept is at 2. And my slope is 1, so I go up 1 over 1. So my slant asymptote is going to look like that. All right, and then I look and see if I have a vertical asymptote. X minus 2. What makes this undefined? Well, if I put a 2 in there, it's undefined. So that makes my vertical asymptote at 2. Okay? Very slick. And then my graph goes like this, and then goes like that. And life is good. All right, so now there is another kind of rational function that is undefined at a value of x, but it does not have a vertical asymptote at that value. Okay, meaning we may have an equation that looks like this. Okay, and x minus 2, if x is 2, we're thinking, oh, well, that's our vertical asymptote. But it's not always the case. So you're thinking, oh great, I had this figured out, you went over this stuff, and everything was step by step, and if I do this, I get this, if I do this, I get this, and everything's fine and hunky-dory. Now we're getting into like the English language where I before E except after C, you know, and then all these other rules that don't quite fit. All right, this is a way that you can find out if that is the case. If, for example, we get what is called a whole rather than an asymptote. All right, so let me first of all draw a graph of what this looks like. I keep saying with a hole in it, and I want to make sure that you understand what I mean by a hole. All right, so we've got this graph that does this, but it says here that x equals, at x equals 2, this is undefined, which means at x equals 2, that line does not go through there. So really what this looks like, they call it a hole because the graph kind of goes up to this little round thing and then jumps over it. So at this place, it doesn't work. That's the hole, okay, because it's at x equals 0. Okay, so, or 2. So how do you figure that out? Well, what you have to do is figure out if you can continue on with this problem, if you can continue to simplify it. So in this case, I can simplify it and cancel those out, and I'm left with x plus 2. Well, that's what this is. It's the line for x plus 2. But because the original one had an x minus 2 in the denominator, that's where the hole comes in. So you take the equation, you simplify it, you cancel it, you graph this here, go back to the original and see if there's a place where this is undefined. If there is, then you put a circle at that place on the graph saying, yes, this line is this equation except for at 2. And I'm going to put a hole there saying you can't go through it. Okay? So that's a key thing. Let me say that again. You take this, you factor it and you cancel it. You'll get rid of anything weird, and you'll just have x plus 2, and you'll have a line. Okay? When I say weird, I mean a parabola, or, you know, it's just going to be a line. It's not going to be any other kind of a graph. And then you go back to the original and find out if all of these points on this line work. Well, what makes this not work? A 2. So therefore, 2 is the only point on this line that makes this not work. So then you put a circle there. Okay, so that's how you tell. Alright, so I am going to need to make a third video. I apologize for that. I thought we could get away with just doing 2, but it looks like it's going to be 3.